I recently bought myself this thing. It's called a klaxon, and here's what it does. Pretty cool, but I want to control it with my Arduino. That shouldn't be too hard, right? I'll simply connect it to one of the Arduino's GPIO pins, pin 7 in this case, connect the Arduino to my computer, and upload a program that waits 3 seconds before turning on the klaxon. So I just turn the Arduino on, and as you can see, it does nothing? Well, the reason for this is twofold. For one, the klaxon runs at 12 volts, while the Arduino only outputs 5 volts. But more important is the fact that in order to get a nice awooga, the klaxon needs upwards of 1 amp of current. The Arduino, on the other hand, is only capable of delivering a mere 40 milliamps. So how do we get the Arduino to turn on the klaxon? Enter the MOSFET. A MOSFET is a type of transistor that can enable a relatively small voltage produced by the Arduino to control a very large amount of current through the klaxon. In general, there are two kinds of MOSFET, P-channel and N-channel. They both work in slightly different ways, but N-channel MOSFETs are much more common than P-channel ones, so we'll ignore P-channel MOSFETs and only focus on N-channel MOSFETs in this video. A MOSFET has 3 pins called gate, drain, and source. At the basic level, a MOSFET behaves just like a mechanical toggle switch. When the gate pin is pulled low, the switch is off and no current can flow between the other 2 pins. But if we pull the gate high, it's as if we've closed the switch and the other 2 pins are now connected together, allowing current to flow from drain to source. As soon as we pull the gate low again, the switch opens and no more current flows. The MOSFET I'm using is the AOI 508, but there are many other kinds of MOSFETs that will also work for this application. The IRLZ44N is another popular one that works great with Arduinos. From left to right, the pins are gate, drain, then source. Let's connect gate of the MOSFET to the output pin on the Arduino, I'll use pin 7 again, and connect Arduino ground to the MOSFET's source. Then we connect the negative lead of the klaxon to drain on the MOSFET, connect source of the MOSFET to ground of the 12-volt supply, and connect positive 12 volts to the other lead of the klaxon. To protect the MOSFET from any large voltages induced by the coil in the klaxon when it turns off, we can use a diode across the klaxon terminals. The cathode of the diode, which is marked by a white ring, connects to the positive terminal of the klaxon, and the other side of the diode connects to the negative terminal of the klaxon. Here I have everything connected up as I just described. Now we can run the exact same code from before, and we see that everything works. This is because the output of the Arduino is no longer powering the klaxon directly, but just controlling the MOSFET gate, and the MOSFET itself is what switches the klaxon. And that's it! Now you know everything you need to be able to use MOSFETs in your own Arduino projects. And you're not limited to just controlling klaxons. Using MOSFETs, you can have your Arduino switch pretty much anything on and off, including motors, lights, or whatever else you might want to control.